Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a video entitled Radical and Exponential Equations. Let's take a look at this first equation. It's a radical equation. We have radicals in an equation where we have equal signs. And what we want to do is we want to try to solve this for x. Now we would solve this for x like we would in any other equation. We're going to get x by itself. So I need to subtract the square root of 12 to both sides. Now, when you do that, you get x equals. However, you can't combine 3 square root of 3 minus the square root of 12 as it is now. So we need to change the square root of 12 in such a way that we might be able to combine it with the 3 square root of 3. So over here on the side, I'm thinking, alright, the square root of 12. Well, the square root of 12 has a perfect square root that's a factor of it. It's the square root of 4 times the square root of 3. And the square root of 4 is 2. Square root of 3. So I have 3 square root of 3 minus 2 square root of 3, which is 1 square root of 3. Or we could just put x equals the square root of 3. Let's take a look at this next problem we have. We have x squared root of 20 minus 3x square root of 5 equals 8. We want to try to get x by itself. Right now, I look at these two different terms and I see there's something in common with both of those. What is in common is an x. So I want to factor out an x. So x times the square root of 20 equals x squared root of 20. And x times minus 3 square root of 5 equals negative 3x square root of 5 equals 8. Now that I have it factored, now I can divide both sides by the square root of 20 minus 3 square root of 5. So divide by the square root of 20 minus 3 square root of 5. And this, I have just x. So now with the denominator, I have a radical in the denominator. So I have 8 over. Now let's change the square root of 20. Right? So you're thinking the square root of 20 has a perfect square root. That's the square root of 4 times the square root of 5, which is 2 square root of 5. So that's 2 square root of 5 minus 3 square root of 5, which is negative 1 square root of 5. So the denominator simplifies to that. Now, you can't have a radical in the denominator, so let's multiply this by the square root of 5. But if I multiply this by the square root of 5, I need to do the same thing here. So that's 8 square root of 5 over negative square root of 25, which is just 5. So my answer is negative 8 square root of 5 over 5. In this particular problem, I have 8 square root of x equals 40. So I want to try to get the x by itself, so it's being multiplied, so let's go ahead and divide both sides by 8 first. That'll give me the square root of x is equal to 40 divided by 8 is 5. Now, to get rid of a square root, we could simply square both sides. So the square root of x squared is just x, and the square root of 5 is, or 5 squared, is just 25. So our answer is x equals 25. And you could always substitute it back into the original equation to see if it works. Square root of 25 is 5. 8 times 5 is 40. Let's take a look at another problem. This is not a radical, but a fractional exponent. So we still want to solve this problem the way that we normally would. We need to get x by itself, so let's subtract 2 from both sides. And that gives us x to the 1/2 power is equal to 7. Now, if you want to change this fractional exponent, it might help you to a radical. This is x to the 1/2 power, or the square root of x, is equal to 7. And we said to get rid of a square root, you simply square both sides. So x is equal to 7 squared, which is 49. Let's take a look at another example. This is the square root of x minus 8 plus 9 equals 2. So we want to get x by itself, so our first step is to simply subtract 9 from both sides. That gives us the square root of x minus 8 is equal to negative 7. Now at this point I would stop. Normally think you square both sides to get rid of the square root. However, I see that I have a square root equal to a negative number. That's not possible in real numbers. You can't get a square root of a number that equals a negative number unless you're talking about complex or imaginary numbers. So in this particular problem, we would say that it's an extraneous solution, or it's an empty set. There is no solution to this problem. In this next equation, exponential equation, I have 2 to the x power equals 16. It's simply asking 2 to what power equals 16. Now this one you could probably work out in your mind, because we know, or hopefully we know, that 2 to the 4th power, 2 times 2 times 2 times 2, is equal to 16. So then x in this problem is simply just 4. We were able to just look at that one and figure out what the answer was. Now let's take a look at an exponential equation where we don't know what the answer is by just looking at it. We know that 9 to the 1st power is 9, and we know that 9 squared is 81. Now we need something that's going to be in between there, something between 1 and 2. 9 to what power equals 27? So the way we do this is we try to get these numbers into their prime factorizations. 9 is the same thing as 3 squared. So that's 3 squared to the x power. And 27 is 3 cubed. You're going to be looking for the same prime factor number on each side of the equation. Now, power on power, multiply. So that's 3 to the 2x is equal to 3 cubed. Now, when you have the same base number, there is a property of equality for exponents that says if you have the same base number and they're equal, then these exponents must be equal to each other. All right? So that means 2x must equal 3. So we just solve for x, and so x is equal to 3 over 2, or 1.5, which we know is between 1 and 2. So our answer is x equals 3 over 2, or 1 and 1/2. Let's go back to a radical equation. I have t square root of 3 plus 2 equals the square root of 27. I want to try to get t by itself, so the first thing that I want to do is let's try to subtract 2 from both sides. This gives me t square root of 3 is equal to, I'm going to put the constant first, 2, negative 2, plus the square root of 27. Now, to get rid of the square root of 3, since it's factored or multiplied, I can divide by the square root of 3. That cancels, so I'm left with t equals negative 2 plus square root of 27. Now, square root of 27 could be simplified, we might do that here in a minute, over the square root of 3. You can't have a radical in the denominator, so it's multiplied by the square root of 3 over the square root of 3. So that in the denominator is just going to be 3, and you distribute, so it's negative 2 square root of 3, and 27 times 3 is equal to 81, and the square root of 81 is 9. Now, if we want to split this apart, we can, and say this is negative 2 square root of 3 over 3 plus 3. Either answer is acceptable here. So if you wanted to split it apart, you could. If you wanted to just leave it together, you could as well. In this particular radical equation, we have the square root of y minus 3 plus 6 is equal to 3 square root of y minus 3 plus 8. Let's get the y minus 3 square root of 3's on both sides. So I'm going to subtract this from both sides. And at the same time, I'm going to go ahead and subtract this 6 to take it to the right side. Now, 1 square root of y minus 3 minus 3 square root of y minus 3 is negative 2 square root y minus 3 is equal to 8 minus 6 is 2. Now, I can divide by negative 2, and so I have the square root of y minus 3 is equal to negative 1. Now at this point I'm going to stop because I see that I have a square root equal to a negative number. That doesn't exist. So my answer then is simply no solution or extraneous solution. Let's take a look at one last example. We have an exponential equation, 25 to the x equals 1 over 5. We want to try to get these into prime factorizations, and we can. 25 is 5 squared to the x power. And 1 over 5 is the same thing as 5 to the negative 1. So this is 5 to the 2x is equal to 5 to the negative 1. Since the base numbers are equal, then 2x must equal negative 1 divided by 2, and x is equal to negative 1 over 2. Thank you for watching. God bless.